Hello friends, welcome to my YouTube channel Make Maharashtra, in which you will get educational videos. Now see, around two numericals we have solved, which are different type. Now this one be the third one type. So third type, which is very important, and most of the time in the examination they have asked this type. So you must focus on this numerical. If possible, try to solve with me. Take your pen, paper, calci with you and try to solve with me. It will be beneficial, because in this numerical I'm going to tell you the new method, which is very simple, that is graphical one, and which will gives you the answer immediately within less time. Clear? So I'll start. I'll read the problem. A hydrodynamic bearing has a diameter and length 100. It indicate L by D ratio 1. Clear? And they have mentioned the chart. The radial load on the bearing is 30 kilonewton, that is W. The journal speed 1500 rpm. We'll have to convert it into rps, that is divided by 60. The radial clearance C 100 microns. I need to convert it into mm. We can multiply 10 raised to minus 3. If the viscosity of oil 25 centipoise, correct? It means 25 into 10 raised to minus 9 Newton second per mm square. I told you the conversion in first numerical. Determine minimum oil film thickness, okay, probable coefficient of friction F, power lost in friction PF, quantity of lubricating oil, that is Q, side leakage QS. If and last one, 6.1, if makeup oil is supplied 30 degree, find the average temperature of the specific gravity. Assume specific gravity 0.86 and specific heat. They will give this data. Now find out. So I'll go the sequentially. After reading the data, I'll realize that okay, the chart is given accordingly. I will have to select the value. It is very important from my side which row I need to select as per question given. So that is the skill. So for that, I'll use the nomenclature first. Raymundi's and Boyd method, dimensions. So before that, before going to solve, this is not your first step, but given data is very important from my point of view, because if you write the given data properly, then you are able to calculate answer very easily. So write down the given data. So given data is like that. I'll repeat. I hope you are solving with me. So L 100 mm, diameter of bearing 100 mm, radial load 30 kilonewton, rpm, speed of shaft given, divided by 60. I'll convert it into rps. Now C clearance 0.1. So they have mentioned 100 microns. So I have converted into mm, 10 raised to minus 3. After multiplying that value, I'll get 0.1 mm. Now 25 centipoise they have mentioned. I told you this conversion 25 into 10 raised to minus 9 newtons second per mm square. Now they have mentioned the supplied at 30 degree temperature makeup oil. So 30 degree temperature, that will be the value of temperature T1. Okay. Now rho density given 0.86 and specific heat 2.09. It is the given data, and calculate HO, F, PF, Q and QS and T average. Average temperature they have asked here. So accordingly we need to solve. So first of all, the terminologies, which are the basic equation we need to find out. As I told you, every time you need to start with the given data point of view. Now I can start here with the this Sommerfeld number, because this data is available. So equation is S is equal to R by C bracket square into mu ns by P. Radius given, as they have given diameter, it means divided by 2 radius. Clearance given, mu, viscosity is given, rpm, in rps we need to write, and this will be the projected area. Projected area I can calculate W by L by D. So W is radial load given, and L by L into D we know. So the value comes 3 Newton per mm square. So I put here this value, from which I'll get Sommerfeld number, that is 0.05208. Clear? What I told you, for this you need to find out the value of S. Now this will be the row of S. So I need to find, and I select the row very easily, as like previous one. Now the value is 0.05208. Now check it. 0.0508. Clear? Now see here, the value is not here, but I can say it is situated in between these two. Am I correct? Dear friends, are you getting it? The value of S 0.052, it is situated in between this. Okay, so I will have to write these two rows. Clear? Now I'll move forward. L by D 1. Now S is this much. Now see, after writing the two rows, I have not written here, but you should write. That will be feasible for your calculation. Now the concept I am going to tell you, that is very important here. Such kind of problem ask for 12 marks. Now I'll make 4 columns. See here. See carefully. I make 4 columns. You can see. This is the graphical method. In book they have mentioned other method which is very complicated, I think. So this will be the simplest one and oldest method. You can get the answer very easily. So see, what I know, the Sommerfeld number, bearing characteristic number, correct? S. So whichever I know, that should I take on x-axis, correct? This will be the last column. I'll explain column wise. So now I want to calculate first from the chart HO by C, correct? Now see here, this will be the chart HO by C. So accordingly I will have to select C. For HO by C, first column, what the parameter I need to calculate, that parameter I should write in first column, correct? This we called as a parameter column. Now you can check, this will be the column of parameter, correct? Second column will be upper limit of 2 rows. So see here, this will be the L by D1 and upper limit 0.121 for S. Remember, 0.121 we have, this will be the upper limit, and for the lower limit S is 0.0446. The value 0.05 is situated in between this. That's why I made the 2 columns. Now, clear? Fourth column is for L by D ratio 1 applicable to all, and the value S we need to calculate for 0.05. So I have taken upper limit 0.121, 0.04, and we need to calculate this. Clear? Now this 0.4 and 0.2 value, how it comes? So please listen carefully. Now see here, I said the S value is situated in between these two. That's why this will be the higher value 0.121 and 0.0446. This will be the lower value, correct? We are interested to calculate HO by C, this value. Now HO by C for 0.121 is 0.4 and HO by C for 0.04 is this 2 rows we need to consider, which is the value is situated in between that. Therefore 0.4 and 0.2. That's why here you will get the value is just wait. So 0.4, 0.2, correct? That is according to chart. Chart is given, always remember. Now the known quantity I will kept always on x-axis. So x-axis range we know, lower limit 0.046, we know upper limit 0.121, so lower limit 0.0446, upper limit 0.121. Clear? Now the calculation, which the parameter which I need to calculate, HO by C, and that range we know 0.2 to 0.4. So I will write 0.2, 0.4. Of course 0.4 is on top side, correct? Clear, dear friends? This graph is clear. What I had explained, what I have explained, first column is parameter, second one is for Sommerfeld or bearing characteristic number upper value. For that HO by C value is 0.4 and for lower value 0.2, and the known quantity always should write in x axis. On y axis the calculation, the parameter which we required. Clear? Always remember, the graph is always directly proportional as they have shown here. It means that, see, this is lower limit, this is upper limit, this is lower limit on y-axis, this is upper limit on y-axis. Now we need to calculate this value 0.50. I have mentioned here roughly. So if I know this value, I can project this, I'll get HO by C. Clear? So same we need to calculate. Here we have to make interpolation. See, the values on x and y axis, I'll just compare. See, first of all, y axis, I need to calculate HO by C minus 0.2. First numerator, HO by C minus 0.2. Now go to x axis, 0.0520 minus 0.004. Am I correct? See carefully, because that portion we need to take. If I take on y axis HO by C minus 0.2, I need to take on x axis, this will be 0.05 into these two values. Correct? So I have written, see, V is equal to, now y axis again, max limit 0.4 minus 0.2, and x axis max limit 0.121 minus 0.0446. So I put this value, see. Clear? This is on left side while considering, and right side, which I am going to equate. After equating, unknown is this, so HO by C is how much? 0.219. Clear? I know the clearance, multiply by clearance, I will get minimum oil thickness. Understood? Clear? If any query, you can pause the video, revise it, rewind and play. Clear? Now see, HO by C first part is over. Through that we can calculate. Now what they have asked, see here, minimum oil film thickness, this we have calculated, because directly clearance I can multiply, will get minimum oil film thickness. That calculation also I will show. See here, HO by C will get this much. So C is in micron, I have converted into mm. So HO oil film thickness is 21 microns. You can calculate also in mm, no problem. Clear? This first part is over from our side. Minimum oil film thickness, okay. Then probable coefficient of friction. Probable coefficient of friction, which friction is here in this table. So I need to check this. I know the value is situated in between these two. So friction you can see for 3.21, 3.32 is the maximum limit and lower limit is 1.70. Correct? So this would be in y-axis. I'll draw the graph. See, coefficient of friction. That's why this is the parameter, and for that parameter, this will be the value of that respect to R by C, 3.32 that I shown you in the table, and minimum limit 1.70. So this is on y-axis. I'll write lower limit 1.C, upper 3.22, that is upper one on y-axis. As I told you, on x-axis always known terms. Known means what? Minimum, maximum, and that we want to calculate 0.058. And this graph is also directly proportional. If I calculate this one, I'll get same like previous this one. So see here, again I'll make the interpolation. R by CF, I'll just erase, R by CF minus 1.7. See, I have written here, divided by, on x-axis 0.052808 minus 0.04 is equal to 3.32 minus 1.7 divided by 0.121 minus 0.0446. Clear? Unknown is R by C into F. So I'll get R by C into F 1.84. They are interested in friction. So I'll go for directly friction. See, R by C value from the graph, I'll get 1.88. Clearance we know, radius of the shaft we know, friction is don't know. So directly unknown is friction. I'll get the friction 0.0036. Clear? This will be your second step. So we have calculated this also. Probable coefficient of friction, second step. Third, they have asked power lost. As I told you, power lost is nothing but heat generation. So I can use direct equation for heat generation. C. This will be the equation. Third step. Go step by step as per their requirement. So PF is equal to, we know, power lost, which is also called as a heat generation in the bearing, 2 pi ns into FWR divided by 10 raised to 6. 2 pi ns is known, RPS we'll have to take in RPS, into F friction we have calculated in previous step. W is a radial load, it is in a Newton, radius of the shaft we know, and through which we'll get the power lost, 0.8712 kilowatt. Clear? Here we have covered the third parameter which they are interested, power lost. Okay. Then quantity of lubricating oil. Quantity is nothing but Q, flow rate. Correct? Quality means viscosity. Viscosity is given. So quantity we need to calculate. So it means that we know the minimum and maximum limit from the chart. Take a reference of chart. And Q value. So Q is situated in which equation? This equation. So Q means I will have to take, see carefully, 4.33 and 4.62. So I'll go to draw the, now see, this will be the value. Clear? I'll explain here. Parameter 4.33, 4.62 yes on x-axis, minimum limit, maximum limit as like a previous. On y-axis the data which we need to calculate, that is 4.33 and 4.62. Correct? But always remember, where there is a need to calculate the value of Q, flow rate, so the graph is always inversely proportional. Likewise, this kind of the graph will come inversely proportional. So the value you can write same, but graph is like this, so that if you get this value you can calculate this. So here interpolation is very different. So just listen and try to solve. First, as it is, Q by RCNS minus 4.33 divided by this minus this 2, this 2, this 2 value, and for that this 2 value we need to keep. 0.2121 minus 0.052 is equal to max minus minimum, 4.62 minus 4.33 and 0.21121 minus 0.046. Or everything is same, but instead of denominator at the first stage, you can take the value which is situated in between these two. This is very important for where there is a Q. Dear friends, please remember, where there is a Q, flow rate, we need to take an inversely proportional graph, and for doing the calculation at the numerator we will have to consider this 2. For these 2 we need to consider these 2. Clear? By that we'll get the value is Q by RCNS is 4.59. Okay. Now they are interested to know what will be the Q, na flow rate they want. So just go to next slide. Now see, Q by RCNS we have calculated 4.59. So everything is known, R, C, NS, and this will be the length 100, which is equal to, so Q is 57395 mm cube per second. I told you mm cube per second into liter per minute. So directly you can multiply by 10 raised to minus 6 into 60, or the conversion I have given in the details I have given in the first numerical. So that will be the value. Directly I'll say Q is equal to 3.44 liter per minute. This will be the value of flow rate. So go to the given data, flow rate also we have covered. Now last is side leakage. Side leakage here. Now this chart we have chosen this. So it means that side leakage is situated in between 0.680 and 0.842. Go to next slide. See this graph. We want to calculate QS by Q. Correct? Now for this 0.68 minimum limit, this will be the maximum limit we have considered. This is also Q is there, that's why inversely proportional. So graph is like this. Now the known quantity on x-axis 0.04, 0.21 same. Now on y-axis we need to calculate 0.680 minimum maximum 0.482842. Correct. Now make the interpolation qs by q minus 0.68 divided by 0.21 minus 0.05 here, and same, which is equal to max minus minimum on y-axis, max minimum, x-axis max minimum. So I kept here. So I'll get the qs by q is 0.82. Correct. Now they are interested in side leakage. So side leakage would be, see this, side leakage is qs by q. This value we have calculated. This q already we have calculated 3.44 C liter per minute. That value I will have to take here, and which is equal to, so through that I'll get the value of qs. Are you getting it? This will be the value of qs, side leakage. This will be our fifth point is over from our side. Now we'll move toward what they have asked. See, side leakage is also over. This clear. Now if the makeup oil is supplied 30 degree, find the average temperature. Now see, the average temperature equation we need to find out. Average temperature effect, that we know the delta T. How we can calculate? Delta T is equal to 2 pi ns FWR divided by rho q Cp into 10 raised to 3. So each and every value I put here as per my calculation. So Cp, see here 2.0, and q, that rho, that is kg per meter cube. It is in given, so that's why I'll take 860. I think I'll just check the values they have given. The q value is 860 kg per meter cube. So same value we need to take, that is the value of rho density. Okay. So after putting this is very important. 860 and 2.0 into 10 raised to 3 will get the temperature rise, delta T 8.39. Now they are interested average temperature. So we'll go here, and average temperature is nothing but T1 plus delta T by 2. T1 supplied temperature 30 degree given, and delta T 8.39 divided by 2. This will be your average temperature for given problem statement. Now see, average temperature is, we have calculate average temperature here. So all the terms, HO, oil film thickness, friction, power loss, flow rate, side leakage, we have calculated step by step, but selection is very important. So that's why you need to read this chart carefully. This is the tricky example, critical example, in which this point is situated in between two rows. Earlier it was single row was there, but here we need to calculate when the values are situated in between two rows. I will have to use, or we will have to use, the graphical method. So as like I told you in graphical method, I'll repeat what we did. First column parameter, second column, first column is parameter, second column would be the maximum limit, third one is a lower limit, the known quantity on x-axis, unknown in y-axis, write down minimum to maximum, the directly proportional graph everywhere except q value. Correct. And make the interpolation, you will get the things. Now q value, for that what we did, that the graph is inversely proportional, the change will be, here is very important, many students did their mistake here, the denominator, what we need to consider these two terms for considering this graph. Correct. So after taking this, I'll make the values, and just directly from the graph I'll put and calculate the values which they are required. Is that clear, dear friends? Okay, this is mostly asked numerical, 99% I would say. Clear? So try to practice it more and more. Number of numericals are given on in a reference book, you can refer. Clear? Okay, now this is your homework. Now try to calculate from your side. I'll add this numerical on assignment also. Clear? If any query, comment me, and practice from your side is very important. Don't listen only, just practice it, do the calculation properly. Clear? In next session, and I'll start new chapter over there. Okay, thank you.